welcome to the next episode of Deep Dives. So today we have Hart. Hart is, what are you, CEO, founder? What's your title?
Co-founder. No CEOs in a decentralized protocol.
I know,
right?
You can be whatever you want. Co-founder of UMA. So Hart and I, we've sort of been bumping into each other now for 4 years, I think, in the space. When we first met, before Teller, we were doing a derivatives protocol, and you guys were before the Oracle, also a derivatives protocol, I believe. But like, how did you, I guess we can just start from the beginning. How did you guys found UMA? Was it the same company as the derivatives protocol, or what were you guys doing first with it?
Well, so the idea, like, UMA stands for Universal Market Access. And I think, Nick, you and I are actually like pretty aligned of sitting around in like 2018 timeframe, thinking that smart contract platforms are a pretty interesting way of writing financial contracts, put it that way. And like derivatives are sort of like, I'll call it like a flavor of financial contracts. But my general takeaway, like, I didn't exactly have a thesis this crisp 4 years ago, but the way I look at it now today is that traditional financial products and services, almost all of them are legal agreements. They're like legal contracts. Insurance is a pure example, derivatives are a pure example, but pretty much everything, there is a legal agreement that says, hey, this financial product or service will be delivered to you, and it's enforced by like a legal system. And we were thinking there 4 years ago, we didn't exactly have all the words for it, but thinking how cool it would be to write financial agreements that were enforced by blockchain and economic incentives, not via a legal system. And that's really the starting point of like, how could we build a permissionless decentralized protocol using blockchains plus economic incentives that enforces contracts between entities? And in doing that, we thought about the Oracle problem from day one, and we thought about it in the idea of how do we have an Oracle that can answer any arbitrary question, because if you want to build a generalized protocol for financial agreements, you need the ability to respond to, like, did an event happen? What is the price of something? What an outcome in the real world is. And so that's something we were thinking about from day one. And originally we were like, okay, people aren't going to get this Oracle thing. Let's try to build this sort of derivatives thing that people might grok and get their heads around. And that was kind of like our go-to-market strategy, if you will. And over the last couple of years, we've abandoned that and said, let's focus on the more interesting thing, which is the Oracle problem, which in some ways is, I think, kind of what you did too, right?
Yes, pretty similar. It was sort of more of a direct pivot, I guess you could say. But yeah, I mean, did you guys jump into like raising money for it?
No.
Was that the start, or?
No, we raised money for UMA back, well, before it had a name. We called it Risk Labs, which is still the name of Risk Labs is the name of the foundation that supports UMA. And Risk Labs, our original kind of idea here was a protocol for risk transfer. So how do we write financial agreements generally across on a smart contract platform? And embedded in that from day one was this Oracle design. So we did have an Oracle design that we didn't have fully fleshed out in early 2018, but we did build that Oracle design over the kind of 2 year and a half, basically 18-month timeframe, in addition to the synthetic token aspect of the business. And then we deployed the Oracle design, what we call our DVM, that we can get into. We deployed that in early 2020. And it was live and used in production in like May 2020.
Okay. No, the timeline's helping. Super interesting. And then when
Yeah.
was you guys had the token sale as well, and when was that?
So the tokens were created, it was January 9th, 2020, when we deployed the network, right? They were created and then they were distributed. They were publicly available on Uniswap. This was actually Uniswap V1, right, before V2 was even released. And that was the end of April of 2020 too.
Okay. Yeah, wow. That's like forever ago now, but
right. But
I know.
not that long ago, but yes, also forever ago, right?
Yeah. No, well, anyway, no, the one question I've been asking people, I think you'll be a good one, what has been the one thing, I guess, since the 4 years that you've been thinking about this problem, or maybe even longer, how has like your view on oracles changed, or what was like one big assumption about the space that I guess has changed over the years?
I think a mistake or a limitation in our initial thinking of oracles was really making them around prices. Hey, we want oracles for price data. And I actually think that's something that we moved away from, because I think our particular oracle design actually works much better for non-price data for other events. Did other things happen? So I think that's one thing that I've learned. And I'd also add that I think
Oh no.
idea that the oracle problem is like solved. And Nick, you and I are very aligned on this, where we hard disagree that the oracle problem is solved right now. Like there's a lot of work to be done, and I think it's a very difficult problem, like to get information in a decentralized and trustless way onto a blockchain is a very challenging thing to do. And I think people have begun to trivialize the problem too much.
Yeah. Well, I mean, I think, this is like the week after the Tornado Cash sanctions and everything. Like, I think we're all going back to, maybe we don't have this whole decentralization thing, even at the protocol level, figured out completely. Like everybody had sort of just assumed like, oh, EVMs and EVM forks are all censorship resistant enough. But then now we're finding out that we were sort of wrong in a lot of ways.
Yeah. And there's interesting questions there too. I mean, you can still ask the question, does it matter? Right. And it's like, but the broader point of just making blanket assumptions that something is, or not really critically asking whether something is decentralized or permissionless, can get you into trouble. I think we're very clearly seeing that.
Yeah, cool. All right, well, we're gonna get started on the whiteboard part. So I'm gonna switch over the view. We're gonna go to speaker view. What's your guys' logo? It's like I think it's just your word, right? Like,
yeah. Let's see how good you do. Yeah.
Yeah, like something like.
That's good.
Something like that. Yeah.
Yeah.
It's like.
I like that. I mean, if you want, I can put on a very aggressive. Watch this. Hold on. I can put on a very aggressive background here.
Please no.
Well, I'll put it on and then we can look. Here we go. There you go. A super aggressive background.
Okay, so yeah, it's lands in the M, but close enough.
We'll take that off. Yeah.
Yeah.
But yeah, Nick, how do you want to start? How do you want to get into this?
Well, so I think I know the basics. I'll start like, let's just start from like a user perspective. So we'll kind of go into the Oracle, and we'll probably just go all over the place as far as how governance goes into it, and then we can maybe at the end talk products, or like I know you guys have some subsequent products as well.
Totally.
But first off, what chains are you guys up on?
We are on Ethereum primarily, and then many of the L2 chains, Optimism, Arbitrum, we're on Boba too, actually. And we'll be on ZK Sync. And we are on Polygon. And then we have what I'll call beta deployments on Avalanche and Evmos and Gnosis Chain, right? And the beta deployments I'm calling beta because there's an additional trust assumption in them that we can get into too.
Yeah, okay, so we'll just work with the base, I'm guessing, because you guys, your main token's on Ethereum, right?
Tokens on Ethereum.
So we'll do Ethereum. So you guys have, this will be our smart contract or our Oracle contract on here, and then we'll do a user over here, and he wants some data on chain, right? Let's say, what's the example you guys give? Do we want to do? I usually do price feeds, but you guys don't like price
let's
feeds.
Let's not do a price feed just to showcase like other things like an Oracle can do. Let's do like who won a hockey game or something. What's your favorite sport, Nick? I don't know.
Yeah, I'm an NFL guy, so we can.
Great. Who won the Super Bowl?
Yeah, who won the Super Bowl? So he would. What does he do first? Does he have to talk to the Oracle first, or does he?
So I
ask
think
the question?
This is where I'll add in a component that has evolved since we like launched the Oracle network in 2020. So the way I'd say it's like we have 2 layers to our system. The first layer is what I'll call the optimistic Oracle. And then the second layer is what we call the DVM, or our data verification mechanism. So the idea here is the optimistic Oracle. The name is maybe a misnomer, where in the optimistic path, it's hardly even an Oracle, right? It's more of it's an optimistic verification system. And only if there is a dispute, only in the pessimistic case, does it go to the DVM or to all our token holders to actually ask what the right answer is. So you can think of it as like an optimization problem or an escalation game, so that we don't need to use this expensive Oracle system very often.
So most of the time, so like the Super Bowl guy, he would set it up in his smart contract where they would have, say, a prediction market. People are betting ETH that says, who won the Super Bowl? Was it who played last year? It was and I don't even remember.
Wait, you're the NFL fan. We're gonna look like such computer nerds if we can't. Like, I also don't remember. I'm not a sports guy.
It was the Rams and the Bengals, and so you would say like, okay, so which is exactly why I don't remember it. And, so you could say like, was it the Rams or the Bengals on 2 sides, and then you would wait, I guess, until it was over, and then the user would theoretically just put it in himself, right? He would say.
Yeah, so let's go like a layer deeper here. So we have something that we call like a price request. So the function name is request price. This is an artifact from when we focused on prices. So frankly, it should be like request data. But basically, let's just we'll call it a data request because that makes it make sense. The smart contract makes a data request to the optimistic Oracle here, and it asks a question, and we can go quite deep into the types of questions you can ask, because the power of the system is it's very open-ended. You can define different structures of the types of questions you're going to ask here. But we're going to ask a question here where we want to know, did the Rams or the Bengals win the Super Bowl, right? And the question is structured such that if the smart contract responds 1, the Bengals won, and if it responds 0, the Rams won, let's say. So we go and we do this price request to the optimistic Oracle that says, did the Rams or the Bengals win the Super Bowl? Anyone now can respond to that price request. Anyone on the blockchain can respond to their price request, and they can say,
are these called reporters? Are they staked? Are they?
We call them proposers, right?
Proposers.
And yep. And anyone that proposes does need to stake a bond to propose. The size of that stake is controlled by the smart contract that makes the request. So it's a parameter of that request.
So details, stake amount. So they would have to, let's say this guy, he would come in, he would put down, it's going to cost him 3 tokens. I mean, what's an average?
We don't do it in UMA tokens. It's also like, that's the other thing where it's like, you don't have to do the bond in our token. So it could be the stake is 2000 USDC or DAI,
Okay.
or 2 ETH or whatever. But like,
Is that like a normal amount or something?
yeah, a couple $1,000 is like a normal amount. A couple $1,000 of value is a normal amount. Related, if we're going to be on the details here, there could also be a reward offered by the calling smart contract for proposing this data. It's optional. You don't necessarily need that depending on the design of your system and what you're asking. You don't necessarily need to incentivize these proposers.
Well, theoretically, he could be the reporter as well.
Exactly. So that's where it depends on the design of your system, whether that reward is necessary. But this is our structure. So the proposer then proposes, actually, and Nick, let's add one more important detail in the parameters of when you make the request, which is the challenge period. In the smart contract, we technically call it a liveness period, but this is like how long a dispute period we have for the proposed answer.
So what's like a usual amount there?
2 hours, let's say.
2 hours? Okay.
Yeah. The idea here is that you need this period to be long enough that if there's heavy congestion in the blockchain, you can still get a transaction through, and there's some time for people to kind of see what's going on. Yeah, that's like the minimum requirement here. So a proposer comes along and they respond to this data request, and again, it could be the original caller that acts as the proposer here too. But they come along, they post their bond, their 2000, their 2000, sure, the 2000 USDC bond. Maybe USDC is not our friend anymore, but you get the idea. They post the 2000 USDC bond and their answer, which, Nick, who won the Super Bowl?
It was the Rams who won. So.
Okay, the Rams won. Yes. LA Rams, I should know this. So they say the Rams won. The clock on the challenge period then starts as soon as that proposal is made. If nobody challenges that answer, nobody disputes that answer in this 2-hour challenge period, then that answer gets taken as truth, and the smart contract can call that data back and find out that the Rams won. We do some fun things here too, where
there would be like yes or no. I mean, what's it cost, I guess? So if you wanted to dispute the answer,
yeah,
what's that cost?
So yeah, let's just basically say, so the optimistic path here, the happy path, is that no one disputes the answer, right, and there's an incentive not to. And 99.99% of the time, people don't dispute the answers that are proposed here because it doesn't make sense. And so again, happy path is after the 2-hour challenge period, contract finds out that the Rams won and they move on with their day, right? Now, in the pessimistic path, there's a dispute that gets issued or called during that challenge period. The disputer has to match the bond of the proposer. So here, the bond of the proposer we said was 2000 USDC. So the disputer goes ahead and matches that. They have to post 2000 USDC, and they say they disagree with what the proposer put forward.
$2,000 USDC. And then he posts it in here.
Mm-hmm.
And then you get a dispute, right?
Yep.
Okay, cool. And now I guess the smart contract, so this is probably where we differ from Teller. Now, now it kicks over here. Nobody else can report on it, right? You're gonna wait for the result.
Yeah, the calling yes. So now the optimistic oracle request that was made originally here, so that initial data request call, right? That is now blocked. The answer to that is blocked pending the outcome of this. There are ways you could write like the contract that's implementing this oracle could say, hey, if a dispute happens, I'm just going to make another data request, right? So I'm not going to wait on this. I'm going to make another data request just to have it happen again. That's like a design choice of the contract that's integrating the system.
Well, that's like what you would probably want to do if you were trying to like price feeds or something where you wanted a little bit of liveness, right? Or did you have some different setup for price feeds?
No. I mean, I think like there's an example where we have a cross-chain protocol called Across that we can maybe talk about a little bit later. Across uses the optimistic oracle to verify repayments to relayers in our network. And if there's a dispute, what the Across protocol actually does in that case is says, okay, we're going to let the proposer and disputer kind of like duke it out in this escalation game to see who gets their bonds back, who makes money there. We're going to then just let anyone propose a new set of repayment instructions on the system, right?
So cool.
Okay.
That's more in the design of their smart contract. You would hope that.
Yep. That's in like the design of the integration, we'll say.
Yep. Cool.
So cool. So now we are escalating. So this optimistic oracle game, we're in the disputed case. We're now going to escalate it to what we call like our DVM, or our data verification mechanism, is what we named it in a white paper a long time ago.
Do you regret
to
this?
be DVM, I mean, I don't know. It's sort of funny as a name, like names that stick around. It's too close to DMV, right? Which is kind of funny.
Well, I think it's like a EVM instantly.
Yeah, I guess I actually haven't thought about that. Maybe whatever. It's not a virtual machine. It's a data verification mechanism.
We're not changing it. Move on.
Yeah. And it is, it's highly informed by, like, Vitalik wrote that Shelling coin paper way back in 2014, and also highly informed by some of like Augur's decisions too here, how this could work. And then to be very clear in kind of our history, the DVM is actually what we started with. This optimistic oracle escalation game is something we've come up with in the last couple of years, because it actually like means we don't have to use this DVM thing as often.
Yeah.
Okay, so the DVM then goes and says, okay, we have a price request to the DVM. We'll call it a data request to the DVM. And it's the same question that we asked the optimistic oracle. Did the Rams or the Bengals win the Super Bowl, right? And now what we are going to do is ask all the UMA token holders to vote on the outcome. And they vote on the outcome in a two-stage commit reveal process, so that they, by default, you can't see how other people are voting. And the game theory behind this system is that people should vote their beliefs, and we should have a Shelling point outcome where the only answer that game theoretically makes sense for people to vote is what they believe to be true, and the voters align on the truth here.
And then, so like this would be the token holders that would do a commitment and then reveal. It's the same basically as if you were just voting with your tokens, right? It's just, it prevents seeing what other people are doing. Right?
Yeah, and the idea, just to spell it out for everybody that's kind of listening, right? Like, we want each voter to do their own work, right? The game theory could fall apart if somebody wrote a script that says, hey, I'm just going to vote however Nick votes every time, and they just look at Nick's address and copy him, right? Because that just, as you can kind of imagine, then all you would have to do is bribe Nick and everybody votes the way Nick voted. So we want to make it difficult for people to see how other people are voting, or we want to make it impossible for people to see how other people are voting unless that person purposefully reveals how they voted, which, again, you can still do. When you're voting in secret, the voter themselves could reveal their secret key to decode that message, but there's no incentive for you to do so.
So this would be, you would have token, let's say, here you have 3 token holders and they each have 30%. If 2 people voted that no, the Rams actually won the Super Bowl, not the Bengals, and the last person says no, the Bengals did, this person, let's say, who said the Bengals won, he would lose his money, correct?
So they get the way we have this implemented is the token holders that vote correctly, and correctly here is defined as voting with the majority, they get rewarded. They get their token balance increased. The voter that votes incorrectly gets effectively penalized because the other token holders, because he doesn't get the reward. Right. So and it's also the same with participation, by the way. If you're a token holder and you don't participate, you don't get rewarded. So you are also penalized because everybody that did participate.
So are you penalized the same amount for voting wrong as you are for not participating at all? Yep. Okay, cool.
Yep, you are. And some of that's like an implementation design, because it's much, it's first of all like a weird UX to like lose tokens that are just sitting in your wallet. So again, we do this as like, you vote correctly, you get this reward, you get this number of tokens. And as such, our token holder participations, our voting participation is actually pretty high, even though it's this like 2-step voting process. We have like 30% of our overall token supply, and it's of the tokens that are actually circulating, it's like closer to like 60 or 70% that actually participate in these votes, which is kind of cool.
Nice. So
yeah,
I mean, so how many people is that? So like you said, you guys have like 30, and then are there like a few big wallets that just vote? Like, is this like a maker where like A16Z is your voting?
Yeah, there are definitely like there's definitely a power law distribution in our voter wallet size. Yeah, and so I'm not trying to I don't want to shy away from that and saying that I don't love that, but it is, we do have a few hundred voters. Again, the big guys are big, but there's no voting address with more than, the biggest has 6% of the token supply, a little bit less than 6% of the token supply.
Do you have delegation in your protocol?
We do not.
Okay.
Actually, and that's a really interesting debate too here, that I actually it's sort of something that we keep talking about. Some of the downsides I think around delegation are that it just concentrates voting power even more. So we're trying to strike a balance there.
Yeah, no, there's no right answer. I don't pretend to have one. It's design choices for sure, I think. But back to this. So after they all vote and the Rams came out winning, but is there a farther thing that can happen once the result happens?
There is not in our system.
There's not. So like you can't dispute the result. There's just one round.
There's just one round.
Oh man, it's serious. One round.
Yeah. I mean, so this goes back to, again, design decisions or trade-offs that we made here too, where looking at Augur's design, I thought one of the weaknesses from it, and this is particularly in Augur V1. And again, I'm not actually sure whoever's listening to this will know all the details of Augur's design.
We just had Claros on like a month ago.
Okay.
Claros has a very, very similar system to like the early Augur system. So
yeah, so this idea though of unlimited voting rounds, I actually thought presents a real challenge for many use cases where you could have these things drag on for a very long time without resolution.
Yep.
And so this again maybe goes to where we could talk about like the trade-offs in the Oracle space and what Oracle designs are useful for what here. But for something like Who Won the Super Bowl, I actually think that this design works quite well because, you know, like really the what I have a lot of faith in and what we've demonstrated now for 2.5 years is the UMA DVM system for a question like that. It resolves correctly. Like nobody's voting incorrectly on that. And so it seems wasteful to have an unlimited sort of escalation game. If you were to ask a question that's way more subjective though, which is where Claros is, I think, where their strength is. If you ask something way more subjective, then I think it could make sense to have a series of escalating votes that go through.
Sure. Yeah. Well, I mean, this one, you know, like I think the difference, it's sort of very similar. Like I think you guys would probably position yourselves, at least I would position you more as like a competitor for like Claros than like a price feed Oracle or something.
It's in between, right?
Yeah.
So like, and kind of purposefully so. So it's again, I think like the Super Bowl question here actually works pretty well. Like I you know, after a couple of days, you know for fact who won the Super Bowl. It's not really debatable, right? I think
so.
see.
Yeah, well, I mean, you could talk like what's the cost to break. At least this piece would be to buy up 50% of the tokens that vote.
Yep,
that would be the cost to break. So you have a decently high market cap. If it's, you know, like let's say it's $200 million, it would cost you, you know, $50 million or whatever to break this. And
yep, exactly.
So yeah.
So, you know, Claros's strength is, I think, is things that are more subjective than a question like who won the Super Bowl, right? And we like very specifically, I think answering those more subjective questions is really quite tricky. Like, I think that's I think those questions, that design challenges there get harder. And so it requires things like more escalation rounds and the potential for a lot longer time until you get an answer. And so I think that's where Claros is focused and specializing.
Yep. Yeah, I know we talked to him. Okay. So no, this is, and the result I guess goes back, but this is I guess the base system you guys have, right?
Yep.
All right.
It's kind of fun, Nick, doing this on a whiteboard with you. This is cool.
Yeah, no, this is fun. Okay, so I think, yeah, so then I guess how does the disputer, does he get a reward here?
So the disputer and the proposer, they effectively double their money with whoever is right. Yep. So if the original proposer, yeah, there's a nuance to that. There is a small fee that gets taken and sent to the DVM system itself. And that's really an anti-spam fee. Because if we didn't take something away, you could actually just be proposing and disputing yourself just to be an asshole and kind of try to break the system.
Well, and if you were one of the voting people, you could essentially just inflate away the non-voting people.
Yep.
No worries. Screw the non-voting people.
So we have like, so we have this final thing, but like back to your point, the incentive for being a proposer or disputer is you effectively double your money for being correct. Okay. Which is kind of cool. And that part, again, the part that, you know, in theory, this was all kind of cool. It's been really cool to see it actually work in practice, where we really do have people propose answers. And if something does get proposed incorrectly, which is rare, but has happened, it gets disputed by random people on the internet. And, you know, like you, Nick, I remember talking to you a few years ago, just, you know, other people like running your node software or whatever that are like random people on the internet. It's very cool to see people on the internet actually doing this and the theory holding true.
For sure. Yeah, no, it's wild when you make software and some Bulgarian is dominating your voting rewards or whatever.
It's awesome.
So cool. Yeah, would love to kind of get into the nuances of what else this would do. So I guess my first question after seeing this system would be, you're obviously up on other systems. So if you're up on, say, are you up on Polygon?
Yeah.
So like, well, Polygon might be a bad example, but say like an Avalanche or something without the best. So like, how would you do Avalanche here? What would be?
Let's do Polygon first, and then I'll talk about where we have
those two are even different.
Yeah, well, because there's a difference here. So it's actually, what's kind of cool about this system is like you can effectively, Nick, like draw a line like under the A between the optimistic oracle side of things and like the DVM side of things, right? Yeah, so those two are different. The optimistic oracle, the code for that is really quite simple, like EVM compatible code that you can deploy anywhere on any chain quite easily. And in the optimistic case where there is no dispute, right, it works and you don't ever need to leave that chain. So for Polygon, for example, we have the optimistic oracle deployed on Polygon. Polymarket uses Polygon actually for their system. So all the Polygon requests, all the Polymarket requests go onto the Polygon network, hit that optimistic oracle. And if nobody disputes it, we never actually leave the Polygon system.
Okay.
If there is a dispute, what we then want to do is have that vote happen on Ethereum mainnet where the UMA token holders live. Right.
Okay, so you would bridge the dispute back over to the DVM.
So we actually we do that, but if you think about the theory here, we don't even really need to do that because the UMA token holders can see that the dispute happened on Polygon. Right, we need somebody to kind of like load it into the system, but they can credibly see, the UMA token holders can see, oh yeah, this dispute happened on Polygon. Somebody's trying to say that the Bengals won the Super Bowl, right? We're going to vote on it and we're going to say what the right answer is. What we then need is after the UMA token holders vote and respond and they've got the result, we need a trustless and decentralized way to bridge that message back to the Polygon optimistic oracle and tell it what the right answer is.
Right.
So Polygon has what we call, I think other people use the same term, but we call it an arbitrary message bridge. So Polygon has a bridge to bridge messages, not tokens, but messages of any kind from Ethereum to the Polygon network. And we have an adapter, we call it an adapter, that works so that a DVM response can get bridged back through the Polygon bridge, Polygon arbitrary message bridge back to the Polygon optimistic oracle. And this shouldn't introduce any additional trust assumptions the Polygon chain does not already have. So if you're on Polygon and using Polygon, you should be trusting this arbitrary message bridge to respond or to believe this response from the Ethereum DVM. Does that make sense?
Yep. No, the Polygon data bridge we were doing something with it like last year. It was like we used so we had like an optimistic type oracle that would fall back to Teller via that bridge. But yeah, no, we're familiar with it. But yeah, I'm glad you got into that, and then
so that
what would be
works.
Also, so like if it came from Polygon, I mean, what would be, whenever they did this dispute here to kick off to the DVM, they would, I guess, have to pay that fee to the DVM. Like what would be the incentive for you guys who are over here in Fleet, like how would the Polygon people know that you're going to support them as token holders and actually submit it back over,
This is where I want to get to one of my engineers did this. So we have done the optimistic oracle deployment on Polygon, Risk Labs has, and it has governance parameters and it's official and it's like documented and all those sorts of things. I'm actually not sure how the final fee is collected. That is a good question. I'd have to ask, I know it is, but that's, I'm actually, because I don't think we bridge the tokens over to DVM, but maybe we do, actually. I'm not sure.
You could just say like, you have to pay the fee on mainnet too, like that.
Yeah, but I don't think we do that. I'm pretty confident we don't. So you've now, like, that's a really, I think we probably have a cool, clever solution that I don't actually know off the top of my head. So,
all right.
Yeah. So yeah, there's like the code is the canonical code and it's supported, and we do use the Polygon message bridge both ways. Like I made the point that technically the UMA token holders can see that Polygon request without us needing to bridge it from Polygon to Ethereum, but for various reasons it's easier and kind of more just a cleaner implementation for us to make that bridge go both ways. So that's what we do to support the optimistic Oracle on Polygon and on Optimism and on Arbitrum and all these things, right? Because they all those chains have a canonical arbitrary message bridge that does not introduce any additional security assumptions versus the chain itself. Avalanche, though, to your earlier point, Avalanche does not right now have an arbitrary message bridge. So we have like a question of like, hey, what do we want to do here? And here we do have an Avalanche deployment that we call like a beta deployment, because we have introduced an additional trust assumption, which is that, again, the optimistic Oracle itself, that code is unchanged, and if nobody disputes it, there's nothing to worry about, or we don't use this bridge. But on Avalanche, if there is a dispute, we use a multi-sig to bridge that dispute back and forth between the Ethereum mainnet. And that's meant to be a stopgap temporary solution. We don't have really much usage on Avalanche right now, but this was to be able to have a deployment there and have it be usable for testing or kind of like low security purposes.
Cool. Yeah, well, I mean, you could always, it's kind of the problem with all bridges at the moment. Like, bridges are basically multi-sigs until I'm sure we can get into a cross, but you know.
Yeah, we can get into it, but like Nick, like in this case, like the multi-sig also, the idea is you could have signers on the multi-sig that are on different teams that are spread around that like don't really have that have a specific incentive not to have this thing be lied to or whatever else. It's just it's an unsatisfying solution in my opinion, right? And so it's like, I think Avalanche, as an example, has told us explicitly that they do want to build an arbitrary message bridge. It's just, you know, somewhere on their roadmap, and you don't know when it's going to happen.
Yeah. So for this one, though, you know, this gets me back to, you know, you guys are adding more and more chains, and if you're picking up things, this is done through inflationary rewards, right? They're paying the token holders. Is there a cap on that, I guess?
No.
So what is it, I guess, what's the reward per, is it like 1% or?
Yeah, we can, well, so the reward right now is per vote. There is a 5 basis point, so you know, 0.05% increase in the number of UMA tokens, and that gets distributed to the token holders that voted correctly. So in other words, if a third of our supply is actually voting and voting correctly, their reward for voting for that vote would be 15 basis points, 0.15% or point. Yeah.
Yeah. So I guess where does it, what would be the, the one thing we've had issues with on mainnet too is like voting costs, or do you guys have to vote with gas? Is that something you guys do, or snap?
Yep. No, right now, I mean, so a couple of things, like we've got an UMA 2.0 design that actually changes this specific aspect where we're looking at having users stake their tokens. And if you stake your tokens, you earn a consistent APY, provided you are voting and voting correctly. So there's a flip side here where basically we're trying to like say, hey, instead of being paid per vote, you are getting paid consistently, provided you are being an active and accurate voter. But one of the things that we haven't yet tackled and we want to is figuring out a trustless or decentralized way to have like gasless voting, or other ideas here is like our two-step voting process. It's very important from a game theory perspective, but it's annoying from a user perspective where you have to vote like twice and pay 2 gas costs to do so. That's like super annoying, right?
Yeah.
We have ideas around how to make that be one-shot voting. That's all stuff that's actually, I mean, happy to chat about it, but I think those are all things that we're working on. Our voting costs as they stand right now, like with gas fees now where they are, it's fine. But with gas fees where they were, it was definitely a disincentive for the smaller guy to vote.
Yeah. I mean, we had that same issue where when it was like $50 to $100 to vote, it was like basically, like with your reward, like they're not making money on this. There's no way to, like unless you had thousands of dollars, thousands and thousands.
Yeah, and we've done some other things like out of protocol, and we're actually still doing this, but so nothing to do with the protocol, but the Risk Labs Foundation, which has some UMA tokens, was paying back people's gas fees in UMA tokens out of protocol. So that was just an idea to try to like take some of the edge off of the costs of gas on mainnet. And again, very clearly not a sustainable thing, not something that we intend to do in the long run, but to take some of the pain away from participating in the system as a smaller token holder. That was something that we have done to some success, I think.
Yep. Cool. All right. I think that would be kind of the majority of my questions. Oh, do the token holders vote on anything else? Like, are they governance holders in general?
They are. So this is actually kind of also interesting going back through our history. We built this thing, we built the DVM as this oracle to respond to data. Sounds like there wasn't a lot when we were building this thing, like governance wasn't exactly a concept that people were really thinking about or focused on. And what we ended up doing is like, oh shit, we like need a credible governance process here too. So what we ended up doing is using the same Oracle system we use for data requests to pass governance actions. So it's the same thing where governance requests can be proposed. There is, to propose one, you have to post a big stake of UMA tokens to be able to propose a governance action.
It's like you,
and it's
similar to Uniswap, I'm guessing.
I think it's different because you lose the stake of tokens if you if your vote does not get passed. So it's actually like pretty.
So here you lose it if you don't pass it. Man.
Yeah. So the idea here is we like really don't want people proposing governance votes that are like spurious or dangerous, even, let's say. So you post a slug of tokens, you can propose a governance action, and it goes to our token holders for this two-step voting process, where it functions just like a data request, where people do vote, like if the majority says yes, this should pass, then they get a reward for voting that, and it goes through.
Cool.
So it just repurposes our system for governance too. In a way,
like, is it just like an upgradable proxy, like Open Zeppelin, and then you can go from there, or is it limited in what you guys can do?
It's I don't want to misspeak exactly as to like, but we have different components, like different components can be swapped out, but it is like limited in what you can do here.
So we're like, what are people voting on? Is this like upgrading a contract, deploying on a new chain? Is it more like changing a minting rate or of some sort of?
Yeah, it would be changing parameters, like for example, what the reward rate is for voting correctly. That would be like something you could do. But the real thing that gets voted on are the different types of questions that can get asked by the system.
Oh, so it limits you as far as which ones you can ask?
There needs to be like a structure to how you ask a question. So It's
Okay.
not like, so we call this thing, we have a concept we call price identifiers. So a price identifier, like an example would be a yes or no question. So think capitalized, like yes underscore or underscore no as a price identifier. And that has a specific structure for how you have to ask that question. Token price is another price identifier. There's limitations to how you can ask a question. And the idea here is, again, we want to make sure that we can ask that the token holders can respond accurately to what you're asking. So we try to enforce structure over the question that does get asked.
Cool.
And then other parameters are what types of collateral our system will accept for things like paying, like for things like our bonds that get posted here, right? That's limited by the system itself, and changing those parameters is something that is done via the governance process.
Okay. How many governance proposals do you guys have? Like, how often do those happen?
It sort of seems to go in fits and starts. I really should know this number off the top of my head, but I think we probably had between 50 to 80, like not a small number of, because a lot of these were one-off, like, hey, we want to add this token as something we can use for collateral for proposers or disputers. A lot of them are pretty small actions like that. And there has been a lot of iteration on the price identifiers of how questions get structured. So there's been a lot of questions around that. And what's cool about this reward thing is we actually have had really high voter participation, because you're paid a reward for voting correctly. So in these governance actions, we've observed like very high participation in them.
Nice.
Which is kind of cool.
Yeah. No, I know we're coming up on an hour, but I think the other thing we can look at, so I think this is a pretty good walkthrough of kind of the overall structure of it, but what are you guys are doing? You guys are unique in the Oracle space, I would say, in that you guys build other products.
Yeah.
What are you guys working on that's not the Oracle? I think most of them use the Oracle, right?
Yeah. So, I mean, in some ways, Nick, this goes back again to like 4 years ago when we're doing this. Part of it is like, okay, this is 4 years ago, this was super theoretical. And there's like a question of like, why would people care at all about this thing? Yep. DeFi didn't exist yet. Like, why would anybody find it interesting at all? And so from that mindset, we're like, well, let's build some things people think are cool that use this system as kind of like a go-to-market strategy, if you will.
Oh, cool.
And so the synthetic token thing that we were known from, like, a few years ago, was this idea that people get tokens. Let's make synthetic tokens that track kind of any arbitrary data bit, and we can use our Oracle to power it. So out of that, we've kind of now stumbled on and sort of simplified things is a very simple kind of 2-token contract. We call it like a long short pair, the LSP contract, more acronyms from our past. And this is a contract where you put in 1 unit of collateral and it spits out 2 tokens, a long token and a short token. And at an expiry date, you can decide whether what percentage of the collateral each of those tokens gets. And this is a very simple structure, very, very simple contract design, but you can use it for prediction markets. You can use it for all these other fun things we created called like KPI options, success tokens, and you can use it to build call options too. So we've used this structure to build a bunch of things that are kind of fun.
Cool. Yeah, no, I know you guys got some options, success tokens, and then the new one, I guess, is the bridge as well, right? And that's
and so that's
touched on it throughout it.
Yeah, that's totally different. And for us, we were thinking about here, like, less than a year ago, we're like, it's actually quite wild how less than a year ago, none of these L2s existed yet. People knew they were coming. There was this fast withdrawal problem of optimistic rollups. And we thought an optimistic Oracle design would make a lot of sense for a bridge protocol to communicate across bridges, or across chains, I should say. So we built across as an internal hackathon, honestly. And it worked well enough that we've decided to build it out into its own full-fledged protocol that Risk Labs also supports. So across V2 now is this optimistic bridge that goes across the major EVM compatible chains. So Ethereum, Polygon, Optimism, Arbitrum, Nova, soon like ZK Sync and Arbitrum Nova. And it uses this optimistic design pattern to trustlessly and permissionlessly enable transfers between chains. And we have some cool financial engineering that also lets this happen like instantaneously by inserting this other concept of a relayer. And the thing that's really quite cool about it is like the fees and speeds are very good. So it's very fast and it costs less on average than most of the other bridges in the space. And so we are slowly, like as of right now, we're doing the same or greater volume than our competitors, which I'm kind of stoked about. So it's been cool.
And is it just a token bridge or is it like a arbitrary bridge for messages as well?
It's just a token bridge.
Okay.
At least for now, and for our like that's what we're keeping it focused on here.
No, very nice. Yeah, no, I saw you guys just announced that a few weeks ago, or
the across V2, which is what supports all this other cool stuff and has all this like cool capital efficiencies. We announced about 2 months ago now, 8 weeks ago or so.
Anyway, it was exciting.
Yeah, no, thanks, man. It's been fun. It's also been fun to build a consumer-facing product in addition to building this other like developer infrastructure. It's been kind of cool to do both.
Yeah, no, I mean, building an Oracle, like probably for all the projects we talk on this, like, you know, your ideal customer is like really, really different than a retail user. It's like, you know, you could care less about what retail even understands about your product. And so, yeah, I guess anything else we should know about UMA? So before we kind of wrap up the deep dive piece, you know, did we miss anything as far as how it works? Or
no, I think you asked all the right questions.
Cool. Yeah, I can go back to gallery here. Okay. No, thank you so much for that walkthrough. You guys made like a lot of very, very similar token designs to Teller, which I'm sure you know. I like the inflation piece for paying. I love people just playing around with inflation error rewards. I think that's one of my favorite things about the space. So you guys do that well. So it's nice to see. I guess what's next for UMA, and where can people kind of find out about you guys?
Yeah, I mean, for us, I think there's a lot of wood to chop on what I'll call like developer tooling and making these systems easier to build on and integrate with. And for us, part of the advantage of building some of these protocols, like building across, is we sort of dog food our own protocol and realize all the pain points of integrating it. So we're trying to make our developer tooling way easier and make it so that this really is for other protocols out there that want to ask arbitrary questions, like did so and such event happen, or like I think like validating that your Twitter handle is what you say it is. It's another example, I think, where like this type of Oracle could be useful. We just want to make that really easy to do. And so the kind of the core objective on the UMA side for the next year is really on the developer tooling and the usability, and kind of explaining to people what this Oracle design can get used for. And then on the across side is like, again, this bridge. And for us, it's super fun and simple, where it's just make the fastest, cheapest, most secure bridge. That's just what we're being like super directed around, trying to build a fast, cheap, secure bridge that people use, which is kind of fun.
Yeah. How big is your team now? It's like
28 people.
Nice. Yeah.
Yeah.
No, good stuff.
Yeah.
So, super cool. Well, and then where's umaprotocol.org, or what's the website?
umaproject.org.
UMA Project.
Yeah, we also have uma.xyz, which I think we should use more.
Well,
but
you can say it here first. uma.xyz. Hit it up.
Yeah, exactly.
All right. Well, yeah, thanks for coming on, Hart. This was a blast. Let me know, if there's anything I should add after the fact.
Yeah, totally, Nick. This is super fun. Thank you so much for this.
All right. See you.